Hello everybody, welcome back to another chemistry lesson here. Today we're going to talk about periodic families. But before we get started with periodic families, we're going to first discuss what we've looked at so far. Well, we've learned that Mendeleev created the periodic table and he did it by increasing atomic mass. But then we later on discovered that it was the protons that characterized the element, so now the periodic table is in order of increasing atomic number. But luckily for us, even if we have increasing atomic number, remember we read the periodic table from left to right then down, the masses are also going up. So Mendeleev wasn't that far off. Okay? And then last time, you talked about groups and periods, right? We said the groups run up and down, and the periods run left to right. And we learned that as you go down a group, the number of valence electrons stay the same. And as you go across a period, you have the same energy level, but your valence electrons are increasing by 1. Okay? So that brings us today to the periodic family. Well, we call them families because they have all the same, pretty much the same valence electrons. Therefore, they have similar properties and they react similarly. Okay? Let's take a look real quick. Like group 1, or group 1 valence electrons. So if we take a look, all of group 1 has 1 valence electron. Okay? All of group 2 has 2 valence electrons. Then we have 3 valence electrons, 4 VE, 5 valence electrons, 6 valence electrons, 7 valence electrons, and then 8 valence electrons. Okay? So since we say families are determined by how they react and stuff, then we know that we've got to be looking at valence electrons here and where they stack up. So let's start taking a look at families. The first periodic family we're going to look at are the group 1s. Okay? Right here, group 1. And at the very top of a periodic table, if you look, there's actually a little 1 there. There's a little 2, and then you skip these guys, and you have 3, 4, 5, 6, 7, or 13, 14, 15, 16, 17, 18. But you can look at that as valence electrons. Take away that 1, and that's your valence electrons. So the first family we're going to look at, I'm going to do this one in red, are your alkali metals. Okay, are your alkali metals. That is your group 1s. Okay, your group 1s right here. Remember, all these guys have 1 valence electron. And remember, the goal here is to either fill up that energy level or empty it out. Okay, so these guys right here all have 1 valence electron, but they're in a 2 energy level or higher, so it's actually easier for them to give away that 1 electron and become happy. So they all react the same way because they're giving away 1 electron. Now you notice I didn't circle hydrogen here. Hydrogen's special. Remember, hydrogen is in group 1, or hydrogen is in, he has 1 valence electron, but remember, he's only in the first energy level. Remember, the first energy level can only hold 2 electrons. Let me write that up here. Remember, it was 2, 8, 8, 18. How many electrons can be held in each energy level? Well, hydrogen's in the first energy level, and it can only hold 2. He has 1 valence electrons, but since it's in the middle, he can either give it away or take on another one, so he actually acts different from the other guys. All these other guys are going to give away 1. Hydrogen can give or take. Okay, so that's your first family. Your second family we're going to look at are your group 2. All these guys have 2 valence electrons in their last energy level, 2 of them. So they're going to give away 2 electrons because it's easier to give away 2 than to try to gain 6 more, right? So they're all going to give away 2 electrons. We call these guys the alkaline earth metals. Those guys are your alkaline earth metals. Now we have a big group here, okay? We're going to look at the D's here, 3 through 12, the entire box, okay? 3 through 12. These guys are what we call your transition metals, okay? Those are your transition metals. Then we're going to go to the very end here. Take a look. Move that down a little bit. So now we're going to take a look over here all the way at the end at group 18. Well, how many valence electrons does group 18 have? They have 8. So, guys, you're going to see something here. These guys fill up their last energy level. The energy level is totally filled up. So if you're happy and you have what you need, you're not looking to take on, you're not looking to lose. So you just sit there doing nothing, right? And because they sit there doing nothing, we call them the noble gases. Okay? You know, like nobility, the kings and queens and all them, they don't do no work because they have everything. So these guys, their last energy level is full. They have everything they want, so they do nothing. They don't react, nothing. Okay? So we call them the noble gases. Now, right beside them, we have these guys right here. And these guys have 7 valence electrons. Okay? Now these guys are so close to filling up, they just need one more electron to fill up their last energy level. And these guys we call the halogens. Okay? Those guys are called the halogens. Now let me talk about the halogens real quick and the alkali metals here. These two guys right here. Super, super important thing you need to know. These guys only need to give away one more electron to become stable. These guys only need to gain one more electron to become stable. Because these guys are so close to becoming stable, I mean like really close, one move away, they will do anything. These guys will do anything to gain an electron. These guys will do anything to give away an electron. Okay? And because of that, these two, the alkali metals and the halogens, are the most reactive elements on the periodic table. The most reactive elements, because they are so close to getting stable, they'll do anything to become stable, and that's why they're so reactive. Okay? So now, one last thing, that's something we got to talk about. Let me draw my little square box here. We call these the metalloids. Okay? The metalloids. Now I'm going to draw this zigzag line here. I call it the zigzag line. Okay, let me get that nice and dark so you can see it. Okay, the zigzag line here. Now the zigzag line does a lot. It tells us who the metalloids are. The metalloids are really all the elements that touch. All the elements that touch the zigzag line are what we call metalloids. Okay? All the elements that touch the zigzag line are what we call the metalloids. Well, before I tell you what the metalloids are, let me explain what that zigzag line does. Okay? So I'm going to draw me a little zigzag line here. Okay? All the elements to the right of the zigzag line are what we call nonmetals. Okay? All the elements to the left of the zigzag line we call metals. So there you go. If you're looking at the periodic table and you find the zigzag line, you're going to notice something here. Most of the elements in the universe on the planet are metals. Most everything are metals here. We have very few nonmetals, okay? Very few nonmetals. These guys on the right of the zigzag line are the nonmetals. So that tells me most of everything are metals, okay? So that's why us chemists, you're like, oh man, he's got the periodic table memorized. Well, no. I just look and I know there's very few non-metals, so when I'm looking, it's probably on the metal side, okay? But if you kind of memorized a little bit of non-metals, then you'll always know where everything's at, okay? So let's talk about metalloids now. Since we know this side is non-metals, this side is metals, all the elements that touch that zigzag line we call metalloids. Well, we call them metalloids because they have characteristics. You know, metals have certain characteristics, non-metals have certain characteristics, but these elements who touch the line kind of have characteristics in both of them. They kind of act like metals and they kind of act like non-metals, which makes sense because they're in that transition period between metals and non-metals, right? So that's what the metalloids are the metals or the non-metals found at that transition point and where we go from metals to non-metals. So these guys in the middle who touch the line kind of have characteristics of both. Okay guys, the last two families we're going to talk about are the lanthanides and actinides. The lanthanides and actinides. The lanthanides are this group right here. The actinides are right below it right here. These two are always labeled on the periodic table, these two families. So the lanthanides would be your 4F and the actinides are your 5Fs. Remember that from electron configuration? So just don't forget the last two guys in the families are lanthanides and actinides. Okay, the 4F, lanthanide, 5F, actinide. So that's periodic families, guys. I hope you learned something and have a phenomenal day.